GMAT all day.
In the last video, we saw what happens when we have a single ratio of three things. In this question, we'll see what happens when we have multiple ratios. So this question says, Alvin, Simon, and Theodore are stamp collectors. The ratio of stamps in Alvin's collection to stamps in Simon's collection is 8:5. The ratio of stamps in Simon's collection to Theodore's collection is 7:10. If Theodore were to give Alvin 28 of his stamps, Alvin's collection would be double the size of Simon's. How many stamps are in Simon's collection? So a couple things. As these questions get more complicated, it is important to always, on your first pass through, just try and understand the scenario. Don't worry about the numbers. Don't let the numbers throw you off just because they throw a lot of numbers and a lot of variables at you. The first goal is always just understand the situation. You got these three people. They give you these two different ratios. Then they say there's this exchange of stamps that occurs. And then they ask you for the number of stamps in Simon's collection. That is what is important. If you get sidetracked, you start writing things out as you go, you're going to lose track of just what is happening in the scenario. You can always go back and fill in the numbers later. I don't care about the numbers to start. I just want to understand what is going on. Then, after that, let's just do what we have been doing this whole time. Let's set up our ratio, or ratios in this case. So first we have Alvin to Simon. That is one ratio. That is 8:5. We'll do what we have been doing and say Alvin has 8x, Simon has 5x stamps. We don't really need a total here because that would just be the total between Alvin and Simon, which doesn't really represent anything. Then we have a separate ratio of Simon to Theodore. That is 7:10. The classic mistake people make is if this is 8x to 5x, they then say, well, this must be 7x to 10x. But think about what you are doing if you were to say this. You are saying that my two ratios here have the same multiplier, which would mean if x is equal to 1, if Alvin has 8 stamps, Theodore must have 10 stamps. Or if Alvin has 16 stamps, Theodore must have 20 stamps. But that is not necessarily true. Alvin and Theodore are not related in any way whatsoever. Theodore is only related to Simon. So you cannot give two different ratios the same multiplier. You have to say if this one here is 8x to 5x, you got to say this guy here is going to be 7y to 10y or some other variable. And everything else being equal, so if your two ratios are truly unrelated to each other, it would still be possible that x is equal to y. So in that scenario, you're still taking into account the possibility that that is true. But before, we would have been saying it is necessarily true. And in fact, in this case, our two ratios, they are connected to each other, right? They're connected through Simon. The number of stamps that Simon has here, that's the same collection that he has over here. It's not like he has two different collections of stamps and our two ratios. It's the same collection. And so because of that, in this scenario, it is actually not possible for our ratios to have the same multiplier, because that would mean if we said 7x to 10x, that would mean Simon has 5x stamps over here and 7x stamps over here. Could not possibly be true. So in this case, you really have to assign different variables to your different ratios, because remember, that is what makes your two things in the same ratio, the fact that they have the same multiplier. So if you have different ratios, those different ratios have to have different multipliers. That is what makes them different ratios. But now, so this is the goal. So when I have multiple ratios, my goal is to make a single ratio. Here I have two ratios with two things in each of the ratios. My goal is to make a single ratio of my three things. And to get a single ratio, it means I need a single multiplier. So the way I like to write these is like this. Take my two ratios, instead of writing them like this, just sort of write one on top of the other, and then have how they are linked, if they are linked in the middle. So we got 8x to 5x is Alvin to Simon, and Simon to Theodore is 7y, 10y. So if we were to infer, if this is our setup of our ratio, then we were to say, well, what is this telling me? The only thing we know is that 5x must be equal to 7y. So Simon only has one collection of stamps. And that is how this is not only connecting our two ratios, this is connecting our two multipliers. And so this is how we can get everything in terms of a single multiplier. And it does not matter how you do it. Get everything in terms of x, or you can get everything in terms of y. You can write this as x is equal to 7/5 y, or you can write it as y is equal to 5/7 x. It doesn't matter. It just changes whether or not you're putting everything in terms of x or y. So if I were to say x is equal to 7/5 y, so what I'm saying here is I'm going to put everything in terms of y. That is why I need to know how to go from x to y. So if I'm putting everything in terms of y, what does that mean? Theodore stays the same, right? Because Theodore is already in terms of y. Simon, I can choose. I have Simon both in terms of x and both in terms of y. So if I want to put everything in terms of y, I'm going to choose the 7y as opposed to the 5x. Then Alvin is the one I actually need to convert. So if Alvin is 8x and x is equal to 7/5 y, Alvin is really equal to 8 times 7/5 y, which is 56 over 5 y. So if I were to finalize this ratio, we'll make a single ratio of 3 things out of these 2 ratios. So Theodore is the easiest because we only have one choice. Theodore is still 10y. Simon, we got to choose, so we're going to choose 7y because we're putting everything in terms of y. Then for Alvin, we got to choose this guy here. So Alvin is 56 over 5y. And then the very last thing I might do is I would prefer to have all integer coefficients for my ratio, because all that matters is I keep these things in the same ratio. So I can manipulate these however I want, as long as I do the same thing to each of my values. So I'm just going to multiply this whole thing by 5. So Alvin is 56y. Simon is 7 times 5, or 35y. Theodore is 50y. What I might do is put this all on a new page so we can look at the question. This is my single ratio of 3 things. So this is really still, though, my setup. I've just simplified it. Now here's my change. Now I got to translate this into algebra. If Theodore were to give Alvin 28 of his stamps, so Theodore had 50y stamps before, he's giving up 28 of them. He should now have 50y minus 28. And Alvin, he's gaining those stamps, so he should have 56y plus 28. And they say Alvin collection will be double Simon's. Then they want to know how many stamps does Simon's have. And so Simon doesn't change at all. No stamps were added or subtracted from Simon. We are looking for 35y. We're going to solve for y. That is not our answer. We're looking for 35y. So what do they say? So after this change occurs, Alvin's collection is double Simon's. So double Simon's, he had 35y before, he should have 70y, would be double that. So what is equal to double Simon's collection? It is Alvin after the change, right? So Alvin after the change is equal to double Simon's collection, or 70y. So 56y plus 28, because that is Alvin after the exchange occurs, is equal to double Simon's, or double 35y, which is 70y. Now, I can just solve for y, and then I got to remember my final answer is 35y. So this shouldn't be too hard. 14y is equal to 28. Y is equal to 2. Means 35y is 70. So Simon has 70 stamps.